Hello guys, today we are going to look at number patterns, sequence and series. So we'll be looking at summing the terms of an arithmetic series. So we'll basically be looking at how to derive the equation to find the sum of terms of an arithmetic series. Okay, basically it's the formula that says the sum of n terms, or the sum of terms in an arithmetic series, is equals to n divided by 2 into the first term plus the last term, whereby n is the number of terms that are there in the series, or the one that says the sum of n terms is equals to n divided by 2 into 2a. Remember, a is the first term, into n minus 1, n being the number of terms in the sequence, multiplied by the constant difference d. So we'll learn how to derive this formula today. Now, without wasting any time, here's an interesting story. Legend has it that the greatest mathematician, who is known by the name of Karl, was once menacing in the classroom. So his teacher decided that it was better to chase him outside the class. The only condition that was there for him to return to the classroom was if he could add the numbers from 1 all the way until 100. Now you can imagine how difficult that is. Let's think about it for a second. If you are going to say 1, if you say 1 plus 2 and then add 3, that's already 1 plus 2 giving you a 3, and then plus 3 giving you a 6, plus 4 giving you a 10, plus 5 giving you 15 now. Then 15 plus 6, which is now 21. So you'll see, like, by the time you get to 100, the number will be extremely large. Okay, so this is what he did. He came up with a way. Let's try to narrow down the situation for a second. Let's take the first 5 natural numbers. Let's say we have 1 plus 2 plus 3 plus 4 plus 5, right? And this is an arithmetic sequence, or a series, sorry, because we can see that when we say 2 minus 1, we get a 1. When you say 3 minus 2, we get a 1 again. 4 minus 3, we get a 1. So we have an arithmetic series with a constant difference of 1. See what happens. If we say 1 plus 2, we get a 3. Plus 3, we get a 6. Plus 4, we have a 6 plus 4, which is 10. Plus 5, which gives us a 15. So when you sum up the first 5 natural numbers, it's going to give you 15. Now here's what Karl did. As we can see that here we have the sum of the first 5 natural numbers, meaning it's the sum of the first 5 terms, which is equals to 1 plus 2 plus 3 plus 4 plus 5. And secondly, he reversed the sequence now. He started the sequence from the right hand side, because we know that if I'm going to say 1 plus 2, it's not so different from saying 2 plus 1. The answer is 3 either way. So now he had this as the sum of 5 terms again, which is now equals to, starting the sequence from the right, is now 5 plus 4 plus 3 plus 2 and then plus 1, right? And then he took this as equation 1 and he took this as equation 2. He then said, what happens if I sum up equation 1 and equation 2? He wanted to see what will happen from there. So let's take this whole thing and move it to the right, like there. So he said, what happens if I say 1 equation 1 plus equation 2? If I say sum of 5 terms plus sum of 5 terms, these are like terms, right? So it becomes 2 sum of 5 terms. It's like saying x plus x, which is equals to, what is 1 plus 5? Gives you a 6. What is 2 plus 4? Gives you a 6 again. What is 3 plus 3? Gives you a 6. 4 plus 2, you get a 6. 5 plus 1, you get a 6. So the right hand side gives you none other than a 6 plus 6. So he then said, okay, on my left hand side I have 2 sum of 5 terms, which is equals to, I have 1, 2, 3, 4, 5. 5 6's that are on the right hand side. And then we have 2 sum of 5 terms, which is 5 times 6, that's 30. Even if you do the calculation, 6 plus 6 is 12, plus another 12, which is 24. 24 plus 6 gives you a 30, so it's the very same thing. Then it divided both sides by 2, becomes 30 divided by 2, which is 15. And remember, when we did our mental maths, we found that the sum of the first 5 natural numbers is equals to 15. So So now I want us to think of this in terms of variables and not look at it in digital form like that. What he did then, he said, okay, now the sum of n terms, instead of having a 5, is saying now it's n terms. But now here's what to remember about an arithmetic sequence. The first term of an arithmetic sequence in terms of a and d is known as a. The second term is a plus the constant difference d. The third term, which is a plus 2 multiplied by the constant difference d. So that's what we have for now, right? Yes. So he said sum of n terms in an arithmetic sequence, first term being a, like we said, it's the first term of 1 there, plus, how do we move from 1 to the next term? You see, this is an arithmetic sequence whereby the constant difference is 1, right? Yes. And then from here, the second term is none other than 1 plus 1, which is 2. So it's going to be a plus the constant difference d, plus for the third term, which is a plus 1 plus 1. So it's a plus 2 multiplied by the constant difference d. And then it goes on and on. Now, instead of looking at the series as to what happens when you read it from the left to the right, he said, let's look at it from the right to the left. What happens as you move from the last term all the way to the middle terms? Now, this is what we have. The last, or the 5 there, is known as our last term. It's the last term in the sequence. Now, how do we transition from the last term to the term before it? We simply know that the difference is 1. So when we take the last term and subtract the constant difference, we get the term prior to the last term. So this one is none other than the last term minus the constant difference of d, right? And how will we move from the last term to the term that's there, the second term before the last one? It's none other than saying 5 minus 1 minus 1. So it becomes the last term minus 2 multiplied by the constant difference d. Now here's what I do. If I stop at a plus 2d when I read the series from the left to the right, I'm going to stop at L minus 2d when I read it from the right to the left. So the 2d must always correspond there, right? If you stop at 3d this side, then you must also stop at 3d that side. But remember what we did from there. We said we are going to reverse the sequence now. We said again, still the very same n terms, but now read from the right. So it's L followed by an L minus d followed by an L minus 2d. Plus, we are done with this. Remember, we are reading from here, coming here, coming here. Now we are on to this one, which says it's what? It's a plus 2d. Plus, after this one comes a plus d. So we have a plus d. And then lastly, we have an a there, right? And remember what we said. We said this is our first equation, and this one is our equation 2. So we said equation 1 plus equation 2. Now let's see what happens. We said sum of n terms plus sum of n terms, which gives us 2 sum of n terms. It's exactly what we have right there, which is equals to, remember here we said 1 plus 5, we got a 6. But now what's a plus l? A plus l will give us an a plus l. Plus, let's look at this one. What happens when we take an a plus d and add it to an l minus d? It gives us none other than, since it's a plus there, it becomes a plus d plus L minus D. So we have a plus D minus D. This one cancels that. So this one will give us an A plus L again. We are left with an A plus L there. And then let's look at the other ones. If we look at that one, which says A plus 2D, this one, added up to a what? To an L minus 2D. Again, we see the same situation. The plus 2D will cancel the minus 2D and we are left with an A plus L, right? Remember, this is an A plus L. So even for that, you have an A plus L. Plus, again, look at this, a minus 2D and a plus 2D. So you have an L plus A, which is not so different from an A plus L. Plus, again here, L minus D, A plus D, it gives you an A plus L again. Plus L plus A, which is an A plus L. So you get that on your right hand side. Okay, now this is what we do from here. We have that this is going to become 2 sum of n terms, just like we had there. But in this case, we had 1, 2, 3, 4, 5. We have 5 multiplied by 6s. But now the problem is we have a plus l, a plus l, a plus l. But how many of those a plus l's do we have? We don't know. So it's simply n multiplied by those a plus l. It's n of those, we don't know how many they are. And then from here it becomes we divide both sides by 2, so it becomes Sn, which is equals to n into a plus l all divided by 2, which is n over 2 into a plus l. So now that's how you derive that formula. Okay, now in order to transition to the next one, remember the next one, it says that L is the last term, right? L is your last term, which is also known as Tn. You find it by using the n term. And how do we find the n term in an arithmetic sequence? It's a plus into n minus 1 multiplied by the constant difference. So it means in this equation now, wherever we see the L, we are going to substitute this formula right here. So we have Sn, which is equals to n divided by 2 into a plus, instead of the L we put the a plus into n minus 1 multiplied by d, which then gives us what? Sn is equals to n divided by 2 into, what's a plus a? This is 2a plus into, we have n minus 1 multiplied by d. So that's how you derive the two formulas.